Hello everyone, this is a video lecture for Calculus 2, section 9.3, separable equations. Separable? Separatable? Anyways, so what we're going to do is get y's on one side and x's on the other. That is it. This works because we have a particular kind of equation that doesn't have, say, like a constant value or some other thing that doesn't that gets in the way. Homogeneous comes up to mind, but this is all we're doing, and we've actually done this before back in 9.1, but that was an advanced problem. Not really. It was okay. And so let's do the whole same thing again, and we're gonna have fun doing it. Yay, we're doing calculus. So I'm going to move all the x's to one side and all my y's to the other side. So dy divided by y squared is equal to 3x squared dx. Integrate both sides. This is -2, so I add 1 to the power, divide by the new power. Over here, I add 1 to the power, divide by the new power. Remember the plus c. 3's cancel. This guy here is technically 1 over y equals x cubed plus c. In order to get my answer with y equals, I move both of these around, and so -1 over x cubed plus c is actually equal to the y, which I was trying to find, and that is your answer. The end. See, that was easy. 93003. So I got dy over dx is equal to 3x square root of y. Again, x moves over, y's move over. Dy over the square root of y is equal to 3x dx. Integrate. This is a -1/2. So when I add 1 to the power, I actually get a positive 1/2. Divide by that new power. This is squared over 2. Remember the plus c. When I move the 2, actually, hold on. So this is a half in the bottom, which makes a 2. So I'm going to divide by the 2, technically. And so then I get square root of y is equal to 3 over 4x squared, and then c absorbs it. How do you get rid of your y? Well, you square both sides, and there we go. You might be able to put something else along the way, like this guy right here might actually be the answer. You know, when I was going through, I mean, sometimes I just say, it's the same as the web assigned homework. I'm not actually typing my answers in. I'm looking at their answers and comparing them to what I got. And so oftentimes I have to say, well, mine's equivalent, so we're good to go. If they had given me this and I found this, they're equivalent, okay? But are they equal? And that's, I guess, a good question. So because we have a square root here, and I'm implying that this is a positive right there, when I square both sides, that's cool, but this is kind of like including a plus and minus, because, I mean, imagine that we're going backwards from this one, back the other way. If I square root both sides, I have to have a plus and a minus, and only one of those is actually the correct answer. So just, I don't know, I would be careful. Like, maybe just type stuff in early. Like, heck, just type that thing in and see if it works. There's no harm in trying, at least. Because, again, you could just new randomization or whatever. Du dt is equal to 6 plus t to the 4th divided by ut squared plus... Ooh, that squared is all weird. Plus u to the 4th t squared. Okay, what's going on? Well, first I want to get all my t's on one side and my u's on the other. Yeah, I guess. Because it's not exactly that way. I've still got u's and t's on the same side. So that's a bummer. So that didn't work. So why do I keep typing it? It's weird. Well, you can factor out a t squared here. And that is the trick. That's the key to making this work. You divide by the t squared. U plus u to the 4th all du is equal to now, actually let me do this here, 6 plus t to the 4th divided by t squared dt. Integrate, integrate, and so then I got u squared over 2, u to the 5th over 5. On this side, this is kind of a little weird because I'm distributing my t squared in the bottom, so making a, here, 6t to the negative 2, so I add 1 to the power, divide by the new power, and I actually get this guy. Now this is just t squared, so then I'm going to have t cubed over 3, and then plus c, and you know what? This is what you type in. Type that in, and yeah, you're done. Seriously, don't do anything else. Thinking you need to simplify? This is WebAssign. You don't need to you don't need to simplify in WebAssign. No way. Who told you that? So, no, I'm just playing. You do need to simplify sometimes, but not in this particular case. For e t plus z equals 0. Big pause. See the equals 0 by himself? It's homogeneous. And so we're talking separable. It's all the same. Easy, I guess you could say, is another thing. It all works out together. If you had a constant there or some other kind of number with a t, the whole thing is just completely different. And that's going to be a different class. Like, not even just a different section. It's a different class. I'm going to have to move this over to the other side first. dz dt is equal to a negative 4e to the t plus z. I'm actually going to separate these guys out as well, like this. Notice what's going on. That's supposed to be a z. I have a plus in the power, so powers of powers multiply. No, that's not it. I got multiplying their bases, add their powers. Yes, that's it. So I'm multiplying the bases, add the powers, and that's how it worked to get that guy. I'm going to move the t over here, and I'm going to take the z and move it over there. And so that's dividing it to the other side. So technically it's a negative power. And then for e t dt, integrate, integrate. So I got negative e, negative z, negative 4e to the t plus c, and yep, you're done. Now, they actually want... Okay, it said... Okay, here's the thing. I think we're done. It says, I have a little note here that says, should be fine, but let's do more just in case. And this is a good little demo of what's going on here. So I do want to go and do some more steps, not because it's required, but because it's probably good just in case. So how do I get z by itself? So first off, that negative can come over here, making that a positive, and it's still plus c. The c absorbs the negative sign. Don't put a minus c, that's just dumb. Put a plus c, it's all good. Okay, ln both sides. And this is where it's going to get pretty funky. Cancel those guys out. We got a negative there. Move the negative to the other side. Is there a way to simplify this inside? The answer is actually no. That's better, I guess, but look how weird it is. It's really funky. We don't need that. Just saying. Okay, du dt is equal to 2t plus secant squared of t, all divided by 2u. And they give me an initial condition of u of 0 is equal to 4. So that's a t value, and that's a u value. Okay, so I'm going to move the t over and the u over, and everyone's happy, right? I mean, yeah, basically. There we go. Integrate both sides. So we got u squared over 2. Here we got 2t squared over 2. My integral of secant is actually going to just be a tangent. Derivative tangent secant squared. Then a plus c. And yet again, cancel those. But yeah, you're done. But they have something else. Yes, I have a note here saying that's actually not going to work. Let me rewrite one more time what I'm looking at, and then we'll understand why all of a sudden I actually have to simplify. I know, kind of weird. If I get u by itself, what that means is I got a square root of t squared tangent t and a plus c, something like that. But if you go back to this u of 0 equals the negative 4. Did they say that? Yeah. Oh, no, it's positive 4. Wait, hold on. I just mistyped it. I'm sorry. This is a negative. That's a negative. U of 0 is equal to negative 4. So, because of this, if I plug a 0 in here, I should yield a negative answer in the end. Okay? So far, is that kind of making sense? I should get a negative answer. That's a negative. I need to get a negative. Well, this square root here is never going to give me a negative, but I can get one from right there. So u is technically equal to the negative square root only. Only. Not the positive, because they didn't allow for that to happen. Now we're good, right? Nope, still wrong. Oh, man. What is it now? What we need to do is solve for c, given that we have this initial condition. Again, that's a t and that's a u. And so what I'm going to do is a negative 4 is equal to a negative square root of 0 squared tangent of 0 plus c. That's a 0. That's a 0. So I've got negative 4 is equal to a negative square root of c. The negatives cancel. 4 is equal to square root of c. Square both sides. C is equal to 16. And so now I can finally say that u is equal to a negative square root t squared plus tangent t plus the 16. There we go. Finally done. This is wrong. No. Kinda. They have a u equals, and so you have to only type this part in. But just think about this. The u equals that they include, they're forcing us into a particular format. They're saying at the very beginning that I was not allowed to do this t squared business. I was going to do that. U squared, blah, blah, blah. They don't even want that. They only want this side, and so now I'm already confused. I have to simplify. So I try to simplify, and then it's not plus and minus, so I've got to figure out which one. And then I still got to see, and I got to go and figure out what that one is. Phew. And that's why I'm doing these with you. I could have just skipped it. So find the equation of the curve starting at point 0.04, and it has a slope of x over y. Now that's interesting because x over y is variable stuff. So we're talking a variable slope. And a variable slope basically means a derivative of some kind. I'm saying my slope, my derivative, is equal to y, or x over y. So I could just plug that in directly. So what I'm going to do here is I'm going to rewrite this in Leibniz form. So I got dy dx is equal to x over y. I can move the x, move the y. And so now I got y dy is equal to x dy. Integrate. Y squared over 2 is equal to x squared over 2 plus c. Yep. I'm pretty much done. I need to find c. And so I got this initial condition that I could plug in for my x and y. So I got 4 squared, 4 squared over 2, 0 squared over 2, plus c, solve for c. So I got 16 divided by 2 is an 8. 0 cancels, so there's my c. So my final answer then is y squared over 2 is equal to x squared over 2 plus 8. Awesome. I have a slightly different answer. Don't know why. Yeah, I think I just typoed here. Give me a second. Okay. I was really close, but there we go. That's my answer. I'm going to call it there. So there's another method to doing this. We'd have a positive square root only. So let's keep going just one more step. I don't know if this is required or not. What if I multiply everything by 2? And so then I've got a 16 here. Again, I think that I messed up somewhere. I might have... See, I have an 8. I have an 8 instead of a 16 right here. I think I just messed up on one of my small things. Just warning you, okay? Look at this thing. If that part was wrong and it really was an 8, then maybe I just made a mistake somewhere else. I don't know. So we're looking at this guy, and so if I square root both sides, I get plus and minus. But the thing is that my initial point was at 0, 4, and so we're talking about positive 4, positive value, and so therefore I got a positive square root in order to get this thing to work, okay? I do believe that this is correct. The 8 is wrong, the 16 is correct, because when I plug in a 0 here, I get the square root of 16, which is just 4, which actually makes sense. So I do believe what we're doing is correct. This is good. I'm going to call it there. Moving on. Okay, 93031. I got x squared plus 2y squared is equal to k squared. And they want to find the orthogonal trajectories. Orthogonal trajectories. What is that? So just let's talk for a second. What if I got a curve like this, and I got a curve like this? Notice that at this point right there, it's 90 degrees from one another. Okay? What they're wanting is to find a curve where you get a formula which is 90 degrees from it at all times. What? That's kind of weird, isn't it? How do you do this? There's a formula, actually. And so I'm going to say you find y prime, and then you take the negative reciprocal. Negative reciprocal. This is the key here, negative reciprocal, and then you solve again. Solve is not spelled that way. Okay. So let me go and find out how to make this thing happen for this problem. So I'm going to take this guy down here, and I want to get, again, that's x squared plus 2y squared is equal to k squared. And I want to get y prime. And so to get y prime, I need y by itself. I'm going to move this over, divide by the 2. Y squared is equal to k squared minus x squared all over 2. I'm going to square root both sides, plus or minus, square root. And now I take the derivative. Chuckle, chuckle, chuckle. What's the derivative? Come on. Oh, the 1/2 comes down. Chain rule, blah, blah, blah. It is a mess. It is so a mess. And then you got a plus and minus. Don't. Algebra is cool and all, but calculus is really cool. What if instead I do a derivative at this point on both sides? Basically, I'm doing, here we go, like this. I do a derivative on both sides. I take derivative implicitly, that kind of thing. 2y, y prime. On this side, the 1/2 can come out to the front. The k actually just goes away. And so then I got a negative 2x. The 2.5 cancel. So 2y, y prime is equal to negative x. To get y prime by itself, I can move this over here. So I got a negative x over 2y. And this is gold. We like that. So we did the y prime. Now we want the negative reciprocal. And so how do we make that happen? I'm literally just going to change it now. Y prime now is going to be 2y over a negative x. So that flips it, but then negative in the front. So I'm going to take my fraction, I'm going to flip it, and then I put a negative in the front. Well, obviously, this kind of simplifies it a little bit. You can say 2y over x positive now. So as long as it's a different sign, SIGN sign, and you flipped the fraction, this now is what I'm going to work with. And I need to go backwards, solve for y, and get my functions so I can draw what's going on here. Whew. So that's a dy dx is equal to 2y over x. I can now move the x's over, move the y over, just the y. And so I got dy divided by y is equal to 2 over x dx. My x looks really bad. Okay, there we go. Integrate both sides. And so I got ln of y is equal to 2 ln of x and then plus c. To get y by itself, I'm going to e both sides. And so we get y is equal to e 2 ln x plus c, which I can rewrite as this guy here, which ends up looking like this. But I feel like there's still a way to cancel. That 2 can come out as a power, or come up as a power on the inside. So now it's a square. E and ln cancel. Final answer. Oops, no e anymore. Phew. We wait. That's not what I should have had. Hold on. Where did 2 come from? 2. I should have had a 1 there. I think. No, I have a 2. Okay, hold on. Let me just check my notes. Yeah, 2. Okay, yeah. Okay, yeah. That's cool. Cool. Yeah, that's the answer. That's what I got. Awesome. Oh, okay. Here's the deal. Yeah, that's totally cool. We're good. Moving on. So I had a picture that I was expecting it to look like, but the picture was just my example of a function where you can find all these orthogonal whatevers. That was just me being silly. Okay. So, yeah, we're done. That's it. The end. Cool. Awesome. Let me show you that little picture, by the way, of orthogonal trajectories. Let's just say that I had x squared plus y squared is equal to k squared. This is not what we have. We have a 2 in the front here making an ellipse. And so what we end up with are parabolas, and it's a little different. But this is very similar. This is actually a circle. And so if I had a circle, and I want to know what's a general family of functions that will always be 90 degrees to the circle. Well, how about this? What if I had a line doing this? Isn't that 90 degrees to the circle right there? What if I had a line over here? Isn't that 90 degrees to the circle? And a line, 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 line. Everything's a line. So I want to say my answer for the orthogonal trajectory is going to be a line. What does a line look like? Y equals mx plus b. Well, they're always centered at 0, so you don't even need this guy. Y is equal to mx, and to be more fair in the calculus zone, y is equal to cx. There it is. So this is the orthogonal trajectory there. What we had was an ellipse, and if you want to go way, way, way back to the very beginning, right here, there was a 2 right here, and I want a 1 over here, so when I divide, I actually have a bigger number in the top, so there'll be a smaller number in the bottom. An x major, my y's are half as tall as it is wide. So it's an x major doing something kind of like this. So then what's orthogonal all of the time? It's actually parabolas. I know it doesn't look exactly 90 degrees because my parabolas aren't perfect, but that's the idea, is that I can find 90 degrees. If you zoom into this little point right here, it's crossing through at 90 degrees from one another, okay? And I mean, it's got to be zoomed in. Let me try that again. Yeah, like that. Like this guy is going, and he's going to be going on like this, and this guy's going on like this, and this. But if you look right here, and I mean just like zoom right in right here, you actually can see at this little point here that it's 90 degrees. Okay? All right, cool. That was a long problem, and I think I just made it longer than what I could have done, so, well, whatever. 93040. This is a silly problem. 95 degrees Celsius for coffee. Cup of coffee sitting in a room that's 21 degrees Celsius in the room. Okay, awesome. It has a rate cooling at 1 degree per minute at 71 degrees Celsius. Doesn't this sound so familiar? And they give you this y prime. I'm sorry, y prime. Dy dt is equal to negative 1 over 50. I believe they just give this to you. Y minus 21. Solve. I am not going to solve this because this is an easy answer here. I'm just going to give you the answer. That's okay. Oh, you know, I feel like I messed up one of the other previous problems. Like in my previous recording with this Newton's law of cooling, I think I messed up one of the problems there. Well, I guess I could tell you now more exactly. There's your answer. So how did I get this answer in particular? Why the 74? What's going on with that guy? So notice that we have this 95 and we have the 21, and we're subtracting them to get the 74. Difference. This is the difference in temperature. No, last time I still got the 90 when I plugged in 0. So I don't know exactly what I was doing. I must have messed up somewhere on the last one. This is correct. So if you go back into that previous video about Newton's law of cooling, I think I messed up somewhere there. I'm not going to change it at this point. It was whatever. We did the correct math. It was just them being silly. So there we go. We're good. There it is. Done. Next question. Last question. 93047. So we have a tank of water. I think it's water. 3,000 liters full. And it has with it 16 kilograms of salt. So it's salt water. Pure water is dumped in at 30 liters per minute. And it says how much salt is in there after 30 minutes. Oh, okay. So we have a tank, and it's pouring in, and it's also pouring out at the same rate so that you keep the same height the whole time. And we want to know, like, this is all salty water, but we're trying to put more fresh water in, and the salty water's leaving, but it always mixes up. And so how much salt is left after T minutes, 10 minutes, 5 minutes? What if we keep doing this for like 5 days? Will there be any salt left? Probably not. So I guess what they're wanting is a function with T as what we're going to be doing. And I have to give you a formula for this particular problem to make it work at all. dy over y is equal to negative 30 over 3,000 dt. And so what you're going to do is integrate both sides to get ln of y is equal to negative 1 over 100 t plus c. Notice that I got the 30 and the 3,000 from these numbers right here. Pretty straightforward. They want to solve for y, so I'm going to e both sides. And so I get CE negative 1 over 100t. And that's cool. Just looking ahead here. My initial point was at time 0, we had 16 kilograms of salt. And so I can actually plug that in as 16 is equal to C e to the 0. That, of course, goes away, so 16 is my C. And so my final answer here for the function is 16e to the negative 1 over 100t. And then it says, use this formula whenever t is equal to 10. Find out what y is. And so I plug it in, and I get a 14.5. So, sorry, zoomed in there, I guess. Okay, cool. 14.5. Awesome. That's my answer. There we go. Okay, 14.5. Awesome. Okay, well, that's all I got. Thank you very much. Have a great day.